Welcome to my algebra class. We are in chapter 6, section 3. We're going to be dividing fractional algebraic problems. And number 1, we have 2p over q divided by 8p over 5q, so we rewrite it as a multiplication problem. So 2p over q times 5q over AP. Then cancel common factors. 2 goes into 2 once, into 8 4. Q goes into Q once and Q once. P once and P once. So we get 1 times 5, which is 5 on top, and 4 on the bottom. So our answer is 5/4. Number 2, we're going to change it to multiplication, and then we, because we have binomials, we have to factor, or we make them factors. So we have 5t minus 10 over t minus 5, change it to multiplication, times 2 over t minus 2. 5t minus 10, we can factor that by taking out a 5, so we have t minus 2 left. I'm going to make t minus 5 a factor, since I can't simplify it any further, and t minus 2 a factor. That means I can cancel out the factor t minus 2, and that leaves me 10, 5 times 2 over the factor t minus 5. And if you want to keep that in parentheses so you don't accidentally think you can cancel the 5 and the 10, do that. Or you can drop them. And the last problem we have, next to last, we have some trinomials and binomials. So we're going to change it to multiplication, y squared plus 3y minus 10 over y squared minus 16 times y plus 4 over 2y minus 4. The trinomial can be factored. Product is negative 10. Sum is 3. So 5 and 2 would work. If 5 was positive and the 2 is negative. So the square root of y squared is y. One of these is plus 5 and one is minus 2. So I can cross that out. Y plus 4 is completely factored, so make it a factor. Y squared minus 16 is the difference of two squares, so we can factor it as y minus 4, taking the square roots, and y plus 4. And that's done. 2y minus 4, we can take out a greatest common factor of 2, leaving y minus 2. Now, checking our factors, we can cancel out a y minus 2 and a y minus 2, a y plus 4 and a y plus 4. So that leaves us the y plus 5 on top, and the y minus 4 on the bottom. And those are factors, and we can't cancel them any further, so that's our answer. And the last problem, we'll rewrite this as a squared over b times 2a over b. Change this to multiplication. Write the reciprocal of this as we cube it, b cubed over a cubed. So we can cancel out a b with the b cubed, and that leaves us b squared. We can also cancel out this b with that b squared and leave a b. The a squared cancels with the a cubed, leaving an a, and then we can cancel the a with this a. So that leaves us 2 and a b on top, so our answer is 2b. That concludes the explanation. We're ready to start the assignment. So have your paper out and your books open, page 256, written 1 to 32. Put your heading down, fold your paper in half, and we're starting with problem number 2 on 256. It says divide and give your answer in the simplest form. Instead of writing the division problem, we're going to change it to multiplication immediately. So 2/3 divided by 5/9 becomes 2/3 times 9/5. We can cancel the 3 and the 9, so that leaves us 6 over 5. And leave your answers as improper fractions. I'm going to skip 2 lines because of the canceling. Number 4, I have 3x over 5 divided by x over 15, so that becomes times 15 over x. I can cancel the x and the x, the 5 with the 15. So on top I have 3 times 3 left, which is 9. Problem number 6, I have 3n squared over 5 divided by, so we're changing to multiplication, n 9n over 20, write the reciprocal, 20 over 9n. We can cancel the 5 and the 20, goes to 1 and 4. The 3 and the 9 goes to 1 and 3. The n and the n squared goes to n. On top, 1 times 4 times n, which is 4n. On the bottom, 1 times 3 times 1, which is 3. So my answer is 4n over 3. Problem number 8, c over 2d divided by, change it to multiplication, d over 8c, so we put 8c over d. We can cancel out the 2 and the 8, 1 to 4. The d doesn't cancel, my mistake here. And there is no more canceling, so our answer is 4 times c, which we can write as 4c squared. And d times d is d squared. Number 10, we have 2n over 3m squared divided by, change it to multiplication, 1 over 12mn. So put the 12mn over 1. Cancel the 3 and the 12, goes to 1 and 4. We can cancel out an m and an m squared, making that m on the bottom. And that looks like about it. So on top we got 2 times 4 is 8, n. And we have another n there, so it'll be 8n squared. Over, and all that's left in the bottom is the m. Problem number 12, 9a squared over 2b divided by, change it to multiplication, 6ab, so that becomes 1 over 6ab. We can cancel a 3 and the 9, and 3 and the 6 gives us 2. The a and the a squared goes to a. The numerator is 3 times a times 1, which is 3a. The denominator 2 times b, which gives us 4b squared. Problem number 14, we have 4 divided by, change it to multiplication, the quantity 2 over n cubed. So we're going to cube that and flip it and write its reciprocal. So it's going to be n cubed over 2 cubed, which is 8. We can put the 4 over 1. Cancel 4 and 8, goes 1 and 2, so we have n cubed over 2. Problem number 16, we have 6n minus 2 over 6n divided by 3n minus 1 over 27. 27 goes on top, the 3n minus 1 on the bottom when we write its reciprocal. The 6n minus 2 can be factored. The greatest common factor is 2, so take that out. That leaves us 3n minus 1. Cross that out. 3n minus 1 is factored. We'll just put parentheses around it. Everything is factored, so we can cancel the 3n minus 1 quantity with that one. 6, we can take a 3 into 6 twice, and 3 into 27 is 9. The 2 and the 2. So what's left on top is 9, and on the bottom we just have the n. So our answer is 9 over n. Problem number 18, we have m squared minus 9 over 2m. Change division to multiplication, write the reciprocal, so it'd be 10 over m minus 3. M minus 3 can't be factored, so I'll put it in parentheses. M squared minus 9 is the difference of two perfect squares, so it's m minus 3 and m plus 3. We can cancel out the factor m minus 3, the 2, and the 10, goes 1 and 5. So that leaves us 5 times the quantity m plus 3, and on the bottom an m. And that's all the canceling we can do. Problem number 20, we have 1 over 8 minus 2a divided by, change to multiplication, now write the reciprocal, 3a minus 12 over 5. The denominator here, we can pull out the greatest common factor of 2, and that leaves us 4 minus a. The numerator here, we can pull out a 3, and that leaves us a minus 4. Now, it doesn't look like there's anything to cancel. However, if I check these two factors, they're exact opposites signs, so I can cancel them out as long as I take out a negative 1. So I made the 3 negative. So that's going to be negative 3 over 5 times 2 is 10. Number 22. We have 3 over n squared minus 9. Change division to multiplication. Reciprocal will be n plus 3 over 3n minus 9. The n plus 3 can't be factored any further, so we'll make it a factor. The n squared minus 9 is the difference of two perfect squares, so that will factor to n minus 3, n plus 3. The 3n minus 9, we can pull out the common factor of 3, and we have n minus 3. We can cancel out the n plus 3's and the 3's. So on top we have 1, and on the bottom I have the factor n minus 3 twice, so we could shorten it with the power. So 1 over n minus 3 quantity squared. Problem number 24. We have the trinomial x squared minus x minus 20 over 5x minus 25. Change the division to multiplication, write the reciprocal, x squared minus 25 over x squared plus 4x minus 5. I'm going to take the binomials first. This is the difference of two squares, so that's going to go to x minus 5 and x plus 5. The 5x minus 25, we can take out the greatest common factor of 5, and that gives us x minus 5. The trinomials, this first one, the product is negative 20, sum is negative 1, so the numbers at work are 5 and 4, and the 5 would have to be negative. So x minus 5 and x plus 4. And this one, the product is negative 5 and the sum is 4. Factors of 5 that work are 5 and 1. And since the sum has to be positive 4, the 1 is negative. So this goes to x plus 5 and x minus 1. So let's see what we can cancel. The x minus 5 here and that x minus 5 go out. We can take an x plus 5 out. So that leaves on top an x plus 4 and an x minus 5, those two factors. And on the bottom we have a 5 and the quantity x minus 1. And that's our answer. Problem number 26. We have 2x minus y over 2y minus x. Change the division to multiplication. 4x squared minus y squared over 4y squared minus x squared. on the first fraction, these two can't be factored, so we're just going to make them binomials. This one here is the difference of two squares, so it'd be 2x minus y and 2x plus y. On the bottom, we get 2y minus x, again, difference of two squares, and 2y plus x. So we can cancel out if we start changing signs, we can cancel something out here. So the 2y minus x I think I forgot to flip it. I did. So let me redo that one. I knew there was something wrong there. So I forgot to turn it. So it's 4y squared minus x squared over 4x squared minus y squared. So that now comes out 2y minus x and 2y plus x. And on the bottom it's 2x minus y and 2x plus y. Now we can get rid of something. The 2y minus x's go out, and the 2x minus y goes out. So that leaves us 2y plus x over 2x plus y. And remember, those are factors you can't cancel, so leave them alone. You can drop parentheses if you want, but if you want to keep them in there just so you don't cancel, that's fine. Number 28, we have 8 minus 2p to the fourth over 3p to the fourth. Change division and multiplication, write the reciprocal, so it'd be 6p squared over 2 plus p squared. The only thing that can be factored is the 8 minus 2p squared. We can take out a 2, and we have 4 minus p to the fourth. And that 4 minus p to the fourth is the difference of two perfect squares, so we can break that down to 2 minus p squared and 2 plus p squared. And that's about it. If I take the 2 plus p squared on the bottom over here, I can cancel out those two. The 3 cancels with the 6, making a 2. The p to the squared cancels with p to the fourth, having a p squared on the bottom. So on the top, we have 2 times this 2 here. We have these 2's. So that's going to give us 4 times 2 minus p squared. On the bottom, we just have the, excuse me, the p squared left. So there's our answer. Problem number 30, we have 3 minus 3n over n squared plus 2n minus 3 divided by, change it to multiplication, the quantity 2n minus 2, so we need to write the reciprocal of that. The 3 minus 3n, you can pull out the greatest common factor of 3, and that leaves you 1 minus n. The 2n minus 2, take out a 2, and you have n minus 1. The trinomial, the product is negative 3, the sum is 2. So the factors are 1 and 3, and since the sum has to be 2, the 1 has to be negative. So that breaks down to n minus 1 and n plus 3. Well, the n minus 1 is exactly the opposite of the signs of the 1 minus n. So I can cancel those out and make the 3 negative. So we have a negative 3 on top. On the bottom we have 2 times n minus 1 and n plus 3. And that's our solution, or factored. And the last problem, 32. You have 2x squared minus 11x plus 12 over 27 minus 18x. Divided by, change to multiplication, 6x cubed minus 96x. And that's over x cubed plus 4x squared. This trinomial here, we have to do product sum split the middle. So we'll do that right now. And just do it below the problem. Product is 24. The sum is negative 11. 1 and 24, 2 and 12, 3 and 8 would work if they're both negative. So we're going to split the middle. 2x squared minus 3x minus 8x plus 12. From the first pair, you can take out an x, so you have 2x minus 3. Second pair, the signs are opposite, so we need to take out a negative 4, and we have 2x minus 3. So our factors are 2x minus 3 and x minus 4. So we can cross that out and replace that trinomial with its factors. The bottom, we can take out a 9, and that leaves us 3 minus 2x. The second fraction, we can take out a 6 and an x, and that leaves us x squared minus 16, which is the difference of two squares, so that makes 6x, x minus 4, and x plus 4. On the bottom, I can take out the greatest common factor of x squared, and that leaves us 1 plus 4. Excuse me, it leaves us x plus 4. All right, so now we can start canceling. The x plus 4s go out. We can take out an x here and an x here. That leaves us an x. The 3 minus 2x and the 2x minus 3 are exactly opposite signs, so we can take out a negative 1. And the 3 goes into 6 twice, and 3 goes into 3 goes into 9, 3. So it looks like the bottom is going to be 3x. And the top, we have left the 2 times the negative 1, so we have negative 2 times the quantity, and we have 2x minus 4, so we could shorten that and write it as a power. And there's our answer. That concludes the evens. Be sure you check the odd answers as you do the problems. Get help as you need it.